Hi, thank you for coming to my talk. So let's just get started. So as you can probably already tell from my outfit, I really like to build fun things with LEDs, but I really didn't know that I like to build fun things with LEDs until recently. I've built things like this for this is one of my dogs, and despite his cool demeanor, he's actually very pumped when he gets his rainbow collar on because he gets a lot of attention. So like I said, I haven't been working with hardware that long. It's only for about the past year. And I didn't get into hardware because I had some really practical problem to solve. For my free time, that doesn't really appeal to me. I like impractical things and whimsy and just doing things for fun. And I really got inspired when I visited an art museum in Amsterdam. So this is the Stedelijk Museum. It's a contemporary art museum in Amsterdam. And I went to see an art exhibit by an artist called Jean Tinguely. And if you've never heard of him, he's a Swiss artist from the 60s and 70s. And for him, art is not about standing in a sterile white space and distantly gazing at a silent painting. Art is meant to be playful. And he created these installations that were meant to be triggered by a viewer. So it was meant to incorporate the viewer's experience into the overall effects of the work of art. And it was meant to intentionally blur the line between artist and viewer. So he made several art installations like this, where you could pick a writing utensil, a pencil, or a pen, put it into the art piece, and you trigger it, and it would create an entirely new work of art itself. So it was no longer about just watching a process. By choosing a drawing tool, the viewer plays a crucial role in the creation of an entirely new piece of art. And when I was at the exhibit, this quote by him really stood out to me. It says, "I wanted something ephemeral that would pass like a falling star. The work just had to transpire, make people dream and talk, and that would be all." And this just really stood out to me. I really like this idea of art as this temporary experience that connects the artist and viewer. And it just creates kind of this intimate moment between strangers. And it's just spontaneous. It only is meant to bring joy and inspire, and it only lasts for a short amount of time. So that got me thinking. I was very excited by all of these ideas and things I had seen at the art museum, and I really wanted to figure out how I could use my skill set as a developer and make my own interactive art experience. But unlike Jean Tinguely, I'm not an established artist. I wouldn't consider myself an artist, and I didn't have access to a studio space. I live in a really tiny studio apartment in Amsterdam, so space is very limited. I don't have a place to create and exhibit something. So I started thinking about how I could apply this idea to something that's really accessible, and for me, that was my clothing. So as you can see, this is my outfit, and this is me out in Amsterdam. And then I wanted to make, what was really important to me was to make a really cohesive look. I didn't just want to throw some LEDs on a shirt. I wanted to create something that was coordinated and would look like a complete outfit. So as I started out, as a web developer, first thought about the web app. So I wanted to create some kind of web app that users could pick colors and programs and then send it to my clothes. The next step, which was really the step that had the most anxiety for me, was actually building the hardware into clothing. I had done some small little projects by following tutorials, but I had never done anything like this before. And picking out the different pieces of hardware and really orchestrating everything together. And then the last piece of the puzzle would be actually sending those messages from the web app to the LEDs in my clothing. And for that, I used a library that I'm a huge fan of called Socket.io. I've used it in my front-end web development career. So and it's one of my favorite libraries. So it's just event-based messaging. It works in every browser on every device. And it's pretty simple to set up, so I was confident that my ability to set this up. So I had this great plan. I was super organized. I thought everything was going to be really, really easy. But as you can probably guess, it wasn't. Otherwise, I wouldn't put that slide in. I faced a lot of challenges. At first, I thought most of my challenges were going to come from like wiring and soldering, because it was just like the most ambitious project that I've taken on. But you know, even though I had setbacks that during the process that made me question my abilities, and I felt frustrated that I just wasn't ever going to really get good at soldering and like figuring this stuff out. I tried not to let those setbacks keep me down, and really building stuff, whether it's hardware or software, is really about building iteration, just improving on what you built. So let's just start at the beginning. So like I showed in an earlier slide, so I had this, this was just kind of the diagram. This was my roadmap for my project. So I would just have a web app and Socket.io server, and just deploy that using Node and Express on Heroku. And then I would have my 3 pieces of clothing, my umbrella, necklace, and skirt. And those would just be Socket.io clients. And really, my main focus, I wasn't really focusing too much on the software, so I'm going to not speak too much about that right now, and mainly just focus on the hardware, because that was my biggest obstacle. So hardware. I needed to figure out how I was going to control the LEDs in my clothing, and I had a couple of requirements. So it needed to be small. It needed to be discreet, so it would just kind of fit into my clothing and not look bulky, and I wouldn't have to wear like a fanny pack or something that really just wouldn't fit in with my outfit. It needed to be durable. So since this is clothing, I'm going to be taking it on and off. I wanted it to last so I could wear it many, many times. And my last criteria was I needed Wi-Fi connectivity, because this is how I envisioned that I would be able to connect the hardware to receive messages. So I'm just tethering off my phone's Wi-Fi hotspot. So in my case, I chose the Adafruit Feather Hiza. It's an Adreno, and I chose an Adreno because microcontrollers are really great for projects like this. If you're not familiar with like the difference between Adreno and Raspberry Pi, Adreno just kind of runs a loop, and it's really great when you just want a program to run, and it can be intermittently interrupted and update kind of its state through that, but it's just continually just running a loop and listening. And other reason so I chose the Adafruit because it's an Adreno. It's small. It has Wi-Fi built in, and a big reason was people really love this this microprocessor that uses the ESP8266. So there's lots of tutorials and information. So I just felt pretty confident there was a lot of information I could figure things out on it. So I started on the building phase, and if you've never worked on hardware, you might be curious what that looks like, and this is what it looks like. It's not very glamorous in my case because, like I said, I have a really tiny apartment in Amsterdam, so I don't really have a workspace. So it was mainly just me sitting on a yoga mat on the floor, just soldering and testing and repeating the process for just each of these pieces. And when I was ready to actually go out in public with this, I really tried to think things through. So I didn't want to give people I was interacting with too much context. So I just made up these cards that I could hand without giving a lot of context, without having to speak a lot to them, where they could just go to the web app and interact with it themselves. So I took it out, and I took it out for the first time a few months ago. In Amsterdam, we have a lighted bike ride, which is a lot of fun. People slap a bunch of Christmas lights and things on their bikes, and it's just a lot of fun. And I was really, really excited to take it out, but I want to show you a video clip what happened when I took it out. So as you can see, everything's running really good, and then my skirt goes green, and it's going green, and it rebooted itself. If you can see, it's on a different program from the rest of my outfit. Yeah, my skirt kept crashing, and for the people that are around me that weren't in tech, they were just mesmerized that this was happening and they could go control it. But all I could see was like, oh crap, my skirt keeps crashing, or my umbrella would crash and I have to restart it. And to me, it was really embarrassing because I could see these flaws, and I thought I had built this really durable thing, but it was actually pretty fragile. So yeah, I was embarrassed and disappointed, but I just took it as an opportunity to move on to iteration 2, or how I tried to make it crashless. So with this particular Arduino that I'm using, you can, when you plug it into your computer via USB, you get kind of a monitor. So you can do statements like you would do in JavaScript, like console log statements. And as a JavaScript developer, that's sometimes, a lot of times, how I can quickly debug things. So as you can see with this sample from the log statements, is that it kept disconnecting and reconnecting over and over again. So the Arduino was having trouble keeping a steady connection with my Socket.io server. So I took a step back, and even though I'm like a huge fan of Socket.io, it is made for web applications communicating over HTTP, and it's geared for browsers. So maybe I didn't need that for an IoT project. And, you know, just because the library is available, even if it's a library that you really enjoy, maybe even if someone's created like another version of that for your tech that you're using, it might not be the best solution. So I really just took a step back, and thought about, again, what I was up against when I'm coding for hardware. So when you're coding for hardware, your resources are really at a premium. There's just only so much memory and RAM that you're allocated on these really tiny, tiny microcontrollers. And since I wasn't communicating between a browser and a server for my hardware, you know, maybe I didn't need that extra overhead for HTTP. And I really just needed to find the bare minimum, but still easy to implement and understand messaging library possible. And that's when I found out about MQTT. And MQTT is a machine-to-machine IoT protocol. It's actually what Facebook uses for Facebook Messenger to deliver and sync messages. And it's been around a while. It was invented in 1999 when engineers needed a solution that would allow for minimal battery loss and minimal bandwidth when they were connecting sensors from remote areas in Africa over a really shoddy satellite connection. And I really could give a whole talk about how amazing MQTT is, but I really just want to highlight some of the things that really appealed to me and made me want to do the switch. So it's based on a publish-subscribe architecture. So there's clients that you can integrate, like in my web app, and then the clothing, and then there's a broker. And clients connect to this broker, and that mediates the communication between all connected devices. And what the really key part of this architecture is that when a device connects, it can subscribe to topics. And then when another client puts us a message that has that topic, the broker forwards the message to any clients that are subscribed to it. And I really like this architecture because the publisher and the subscribers don't need to know about each other. They don't have to run at the same time, and operations on both components are not halted during the publishing and receiving of messages. It's super, super lightweight. So it's transported over TCP/IP. It only has a 2-byte overhead, and it's just, they meant to keep it this way. They meant to keep these package headers really small, and every bit in that packet is just carefully crafted to reduce the amount of data transmitted over the network. It means that in comparison to other protocols like HTTP, it doesn't load the network with transfer of information that's just necessary to allow the protocol to run. And then having this small overhead is just really ideal for IoT because it lowers the amount of data that might be transmitted over really constrained networks. Another thing I really like is the MQTT has a really short and readable spec, and it uses simple verbs to describe actions. Basically, there's 5 verbs in MQTT: connect, disconnect, publish, subscribe, and ping. So I was really jazzed up about MQTT, and I really couldn't wait to switch out my Socket.io clients and server and use MQTT instead. So I started with the web app, and for implementing this in the browser, there's MQTT JS library, and you can use it in the browser. And it's written in JavaScript, so you can use it in Node and in the browser. And so I think the code is pretty easy to follow, and that's one reason I really liked implementing this, because it's only really a few lines. So I just require the library, and then I create a client that connects to the URL wherever in the internet I have my broker created. And then in this example, if I have like a rainbow button that people can click on to change my clothes, so I just create a function so whenever that button is clicked, it sends a message to the broker with the topic lights, and that's what I would have my clients, my outfit clients, to subscribe to. And then it can just send the payload string of rainbow. Next, I set up the clients on the Adreno. So this is, even if you're not familiar kind of with Adreno, C++ code is pretty much the same as the other client. So I just include the library. I tell it where the broker is located, which URL on the web, where to find it. And it subscribes to the topic lights. And then whenever a message is received, just this onMessage method is called. And then it can just interpret the message that's sent and then figure out what program it needs to switch to. So I had my clients set up. It was all going like pretty smoothly. And the next was I needed to set up the broker so everything could talk to each other. And just want to show this slide again. So like I mentioned before, I deployed everything just on one Express server on Heroku. And when I went to go set up my broker, even though I really love Heroku because it has a really great CLI that's easy to use, I found out you don't have port access. You can't specify specific ports. And for this MQTT protocol, the port that's specified that you need to use for communication is 1883. So that was a slight hiccup because I couldn't actually build my own MQTT broker. Yeah, so I didn't have access to support. I couldn't set this up. But I was also not quite ready to leave Heroku. I kind of just wanted to see if all this stuff was going to actually work together well before I actually moved to a different service. So I went looking for an external MQTT broker service, and it turns out there's a bunch of them. The one I ended up choosing is called Shifter.io. It's just an IoT prototyping platform. I chose it because it's free, and it's pretty easy setup. You just give your email, and you get a key and a token. And compared to other MQTT broker services, it doesn't seem to limit the number of messages they can receive per minute. Some of them do, and you have to actually pay if you receive more than a few messages a minute. So I tried it out, and it worked like really, really well compared to my first attempt. But I was happy, but I wasn't ecstatic, because here I was relying on this small external broker service, and that really just wasn't optimal for me because there's just a lot of unknowns. I didn't know that much about this company, and I wanted to make something really reliable, and I really felt to make it really reliable, I needed to have control over it. So, as you can probably guess, the next thing I did was I decided to create my own broker. And I had to do that, I had to move from Heroku to DigitalOcean, which gave me a little bit of anxiety just because I'm not that comfortable or skilled yet in doing like DevOps-y kind of stuff. But it worked out, so you shouldn't be scared of that if you're thinking about moving to a service like that. So to build this, I used this broker library called 80s. And what I really liked about this library is just, besides being, using streams and just, it's a really new modern library, is that the broker is embeddable in it would be embeddable in my current Express server that I was using to serve my website. So I would really have minimal configuration change. So I was pretty happy I wouldn't have to build a second server for just handling these messaging. So to implement the MQTT Broker, I just include the library and create the MQTT server and an HTTP server, because like I said, this was also serving my web app. I just specify the ports that each of those need to listen to. So for MQTT, it's 1883, and then my app was just on 8080. And then at the bottom, you can see that, and I think this is really cool as well, is I can add on so that the HTTP server that's serving my website, it can have MQTT over WebSockets capabilities. So those messages coming from my web app, they're just served using WebSockets from the HTTP server. And I was pretty excited because this was working really good, and I had figured out a lot of things, and I conquered DevOps fears. So I was pretty excited. The last thing I did, because I really wanted to make this rock solid, which I hope in a few minutes that I show that it's rock solid, is that I upgraded the microcontroller. So I decided to change to the Adafruit Feather M0 Wi-Fi. And there's a couple reasons for that. So it has low power management, so I wanted to stretch as much out of my battery life as I could. And the main reason was that it has a separate Wi-Fi module. So what that means is it doesn't have to yield all the time to the Wi-Fi core since it's a separate chip. So you get full reign of the processor and timing, and it just means you just have really high-speed, reliable Wi-Fi that doesn't crash. There is a downside, and the downside is that it's twice the cost of the other microcontroller I was using. So the Feather his is around 18 euros, and this costs around 35. But that was a downside that it was worth the extra cost to get the reliability. So it's demo time. So this is probably the biggest audience that I've had that can interact with this. So I invite you to please go to flashylights.nl, and you can play around with my web app and change my... Perfect. You can change what it looks like. I'll just preference this with, this is meant to be like a one-on-one experience, so it might get a little glitchy with so many people sending to it at the same time, but what the heck, like, let's go for it. So while you're playing around at flashylights.nl, I just want to leave you kind of with my closing thoughts that you might not be aware, but I am a super introvert. And this was a really weird experiment to do as an introvert. I am not one that, attracting attention and actively seeking people out to interact with me is completely out of my comfort zone. Sorry. But it was also an experiment that really pushed me to deal with my own reactions to those interactions. And I just really wanted to see if I could bring like a momentary joy and whimsy to strangers by giving them free reign over my appearance. And really, outside of our tech bubble, this is not an application. This is an application like this is not one that most people have seen and experienced. So it was really. I also found that I was kind of breaking stereotypes about tech with strangers. Like they were kind of taken aback when they realized that I had built this, and you could do these kind of weird experiments with tech and kind of question what you can build and who is capable of building those things in tech. And that's it. Thank you for listening. I also build other fun things with LEDs. So if you're interested in seeing those, I'm terrible at blogging at things, but I post pictures on Twitter. And later tonight, I made another piece that's not interactive, but is still really, really cool that I want to wear tonight at the party. So if you see me, say hi. Don't be shy. Thank you.